Hi, in this video, we are going to explain how to solve Kramer's method by Oscar Palos, Abundis Migueles, and me, Samantha Aguirre. Hi, my name is Samantha, and I'm going to explain you how to solve a system of equations by using Kramer's method. So let's start. Well, it gives us the system of equations, so we are going to write them in a matrix form. So we know that A is the coefficient of the matrix, X is the variable of the matrix, and B is the constant of the matrix. So there is the exercise that I write all the coefficients unless the coefficients of the other side of the equal sign, that is 5, 6, and minus 10, to find the determinant of S. In this case, the determinant of A. Then I choose the first row, that is 3, 2, minus 5. Then, depending on the position of the row that I choose, that is 3, 2, minus 5, it depends on what quadrant you are going to use, because if you are using 3, it is not the same the quadrant of 2 or minus 5. So you need to look very carefully what you are doing. Then we are going to calculate the first, second, and third minor by using the labs method, that is multiplying cross and then subtract each other. Like for example, in the first one, it multiplies 4 times minus 3, and then 6 times minus 4, then it subtracts each other, and then it gives us 12. It is the same in the second and third minor. Then, if you already obtained these values, you need to sum all the determinants, and then it gives us 36, 18, 20, by multiplying 3, minus 2, and minus 5, because it is a row that we choose, and then it gives you 74. In this procedure, it is the same by to calculate the determinant of x, y, and z. And that's all of my part. Thank you.
The next step to solve this problem by Kramer method is to solve for each variable. We replace each one of the columns in A individually with the constant matrix B, and we find the determinant of this individual resultant matrix. Delta H will replace column A with B then. We need to basically use cofactor expansion. That means that we decompose the entire matrix using the values of the equations of the three variables that we are given with the constant matrix B, and we find the determinant of this individual resultant matrix. Delta H will replace column A with B then. We need to basically use cofactor expansion. That means that we decompose the entire matrix using the values of the equations of the three variables that we are given at the beginning of the problem, and we solve for each one of them and find delta for each variable for x, y, and z. The first value for delta x in this case is 104, for delta y is 181, and for delta z is minus 64. And then what we need to do is solve for each of the variables for x, y, and z using the same formula for each one depending on the variable. For x, we use x equals delta x over delta, and y equals delta y over delta, and the same goes for z. We substitute the values, each of them, dividing by 74, that was the determinant of A that we got earlier in the solution of this problem. We get the 3 of the values that are decimals, and we need to use them for the next step of the problem.
Well, for the final step, I'm Oscar and I'm explaining you the step 5. Well, we verify the solution by substituting the values of x, y, and z into the original system of the equations. This step is crucial to ensure that our solution satisfies all the three equations. For the first equation, 3x plus 2y minus 5z equals 5, substituting the values of given for x, that is 4.250 plus 4.892 plus 4.325, that equals 5. That is correct. In the second equation, 2x minus 4y minus 2z equals minus 10, substituting the results in minus 1.405 plus 9.784 minus 5.19 equals 6. That is confirmed. That is correct. In the third equation, minus x plus 4y plus 6z equals 6, substituting the values to 2.81 minus 9.784 plus 2.595 equals minus 10. That is confirmed. That is correct. This verification confirms that all the solution is correct and meets all conditions